Here we're being asked to find two partial derivatives. First, let's find the partial derivative with respect to x. Now, as messy as this may look, it's worth pointing out that the function f is a product of two functions of x. And whenever you're taking the derivative of a product, you need the product rule. You may want to hit pause and process how I use the product rule to start this derivative. And now, what I can do is I can evaluate each of the partial derivatives that resulted from me using the product rule. The first one, you may see it in red, is using the fact that the derivative of any exponential function is itself times, according to the chain rule, the derivative of the exponent. The second partial derivative, you may see it in green, is obviously 2. And now I have to compute the derivative that came out of the chain rule. Since we're taking the partial derivative here with respect to x, y is considered held constant. And therefore, this derivative is just 3. Finally, doing a little algebraic cleanup, and then, if desired, factoring out the exponential function, we now have the partial derivative of f with respect to x. Let's change our variable of integration from x to y and look at the other partial derivative we were asked to find. Here, I could use the product rule, as I did before. Something interesting happens. Note the following. If we're differentiating with respect to y, the derivative of 2x, being that it's a constant, is 0. And therefore, the entire last term is 0. And since adding 0 doesn't change anything, we can omit that term altogether. You didn't need to use the product rule at all here. You could have simply realized that f is a function of x times a function of x and y. In other words, the 2x in front of the exponential function can be considered a constant if we're differentiating with respect to y. This derivative here can be found just like we did before, using the fact that the derivative of an exponential is itself times the derivative of the exponent. Again, that's the chain rule. But here, since we're differentiating with respect to y, the derivative of 3x plus 4y, being that 3x is a constant in our view, is 4. A little algebraic cleanup finishes this problem.